All right, let's dive in. Today, we're talking about something that is at the very core of all medical research: sampling. Now, I know it might sound a little technical, but trust me, getting your head around this is absolutely crucial, especially in a field like nursing, where the results of a study can directly impact patient care.
So, to get a real feel for why sampling is so vital, let's start with a question that seems, well, impossible. Imagine you're a nurse researcher who wants to study diabetes in India. There are 77 million patients. How in the world could you possibly study every single one of them? The short answer, you can't. It would be a logistical nightmare. It would take way too much time, money, and people. So, how do researchers get reliable answers?
Well, here's our game plan for this explainer. We're going to tackle that impossible question head on. Then, we'll walk through the process of going from a massive population to a manageable sample. We'll look at what makes a good sample, explore the real-world pressures of nursing research, and finally, get to the big one: why any of this should matter to you. Okay, so as that diabetes example just showed us, trying to study every single person in a huge group, what researchers call a complete enumeration, is almost always off the table. The practical hurdles, the cost, it's just too much. And that is the fundamental problem that every researcher has to solve before they can even start. And this brings us to the really elegant solution: sampling. Instead of even trying to talk to all 77 million people, researchers pick a much smaller, much more manageable group that can stand in for, or represent, that entire population. And this carefully chosen group, that's what we call a sample.
So, how do you get from a massive group of people down to a small, scientifically solid sample? It really helps to think about it like a funnel, where researchers are carefully narrowing their focus at each step. So let's break down what's happening here.
At the very top, the widest part of our funnel, you have the population. This is the entire universe of people or things that a researcher is interested in. It's the big group we ultimately want to understand. From there, we narrow it down a bit to the target population. This isn't just all people, it's the specific group that fits the study's criteria. So for our example, it's not just everyone in India, but specifically the diabetic patients in India. This is the group we actually want to talk about. And finally, we get to the very bottom of the funnel, the sample. This is the small subset that is actually chosen to participate in this study. The data gets collected from this group, and here's the magic: if the sampling is done right, the findings can be generalized all the way back up to the entire target population. This slide really just ties it all together beautifully. You can see the whole journey right here. From those 77 million people in the target population, they narrow it down to an accessible population, say 50,000 patients they can actually reach in certain hospitals. From there, they create a list of eligible patients, called a sampling frame. And from that list, they finally select their study sample of just 400 people. But look closely at that warning sign: potential bias. It's a risk at every single step. And that is why the method you use to pick those 400 people is everything. Which brings us to a super important point: not all samples are created equal. A bad sample can completely sink an otherwise great study. So, what exactly are the ingredients for a sample that you can actually trust?
Well, a good sample really boils down to three key things. First, it's got to be representative. Think of it like a perfect miniature version of the entire population, mirroring all its important characteristics, like age, gender, you name it. Second, it needs accuracy, which is just a way of saying it's free from bias. The scales haven't been tipped in one direction. And third, it needs to have an appropriate size. It has to be big enough to give us confidence in the results, but not so big that it's impossible to study. It's a bit of a Goldilocks situation. It has to be just right.
Now, to get a sample with those qualities, researchers have two main toolkits. On one side, you have probability sampling. This is the gold standard. Think of it like a lottery where every single person has an equal and known chance of being picked. It's what allows for really strong conclusions. On the other side, you have non-probability sampling. Here, the selection is not random. And honestly, this is way more common in real-world nursing research, simply because of practical limitations. And here's a perfect illustration of one of those probability methods. This is called systematic sampling. It's so straightforward. You just get an ordered list of your entire population, and then you pick every, say, third person on the list, just like you see here. It's a simple but really powerful way to get a random group.
So we have the ideal, that gold standard of probability sampling. But then, of course,
there's reality. In the fast-paced, complex world of healthcare, picking a sample isn't just a statistics problem. It's a constant, tricky balancing act. Let's see how that plays out.
The simple truth is, in most clinical settings, that gold standard just isn't possible. So what you find is that most nursing studies and clinical trials actually end up using non-probability methods. Things like convenience sampling, where researchers basically recruit patients who are easily accessible. And, the decision of which method to use comes down to a whole laundry list of factors. It's a puzzle. Researchers have to ask themselves, what are our goals? Can we even get access to the right patients? Do we have the time and money for this? Are there ethical issues, especially if we're working with vulnerable people? Do we even have a decent list to draw our sample from? They even have to plan for people dropping out of the study over time. It's a lot to juggle. Okay, so after all this talk about funnels and bias and methods, let's bring it all home. Why should any of this matter to you? Well, because the quality of a research sample has very real consequences for your health and the care you receive. This quote from one of our sources really says it all. If the sampling technique is poor, the findings might be compromised. In other words, if you mess up the sample, you've pretty much messed up the whole study. The foundation is cracked. And this is the bottom line. When sampling is done right, the research gives us solid evidence we can trust. But when it's done poorly, that evidence is shaky. Imagine a new heart medication is tested only on men between 40 and 50. The results look amazing, but that sample is biased. What happens when doctors start prescribing it to women or to 75-year-olds? It might not work, or worse, it could be dangerous. That's how a bad sample leads directly to flawed medical advice that affects real people. So that leaves us with one final thought. The next time you see a headline about some amazing new medical breakthrough, I hope you'll pause for just a second and ask yourself one simple question. Who was in their sample? Because as you now know, the answer to that question tells you pretty much everything you need to know about whether you can actually trust the results.